Dear students, welcome. This is our sixth class on civics. Today, I shall try to solve these three problems. First, these three problems, 22 problems have already been done. Today, first try to solve the question number 23. And today's question number 1. What is this? Prove that the magnitudes of the components of a force P along two directions, making angles 45 degree and 60 degree on opposite sides of the force are this and this. Suppose this is a force. This force is P. The force is P. Suppose it is acting in the direction OC. Suppose OA and OB suppose OA and OB be two lines such that the force P makes an angle 45 degree with OA and 60 degree with OB. 60 degree with OB. Then we have to find the component of P along the direction OA, and we have to find the component of P along the direction OB. Right. Let the force P be acting at O. Be acting at O. Suppose in the direction OC you may write like this. Suppose OA and OB be two directions such that, suppose we are to find the components of R, components of P along the directions, OA and OB, where the force P makes an angle 45 degree with the direction of OA, and the force P makes an angle 60 degree with the direction of OB, and the same force P makes an angle 60 degree with the direction of OB. Suppose this. Therefore, the component, suppose P1 and P2. Let P1 and P2 be the components of magnitudes. Be the magnitudes of the components. Be the magnitudes of the components of the force P along OA and OB respectively. Along OA and OB respectively. What we have supposed? That P1 is the component of P along the direction of OA, and P2 is the component of P along the direction of OP. Therefore, P1 should be equal to P sine 60 degree divided by sine 60 sine 45 degree plus 60 degree. And P2 equal to P sine 45 degree divided by sine 45 degree plus 60 degree. In the first lecture, I deduced a the formula component, suppose R1 equal to R sine beta divided by sine alpha plus beta. You see this. And the another component is, suppose R2, another component is R sine alpha divided by sine alpha plus beta. Alpha plus beta. This is R, and suppose it is R1 and R2 component, magnitude of the components. It is alpha and it is beta, and the whole angle will be equal to alpha plus beta. Thus, see the lecture number 1. I derived this formula. This formula has been used here. P sine beta. For beta, we have written 60 degree. For alpha, we have written 45 degree. Therefore, P1 equal to P, it is root 3 by 2 sine 105 degree. It is 105 degree. And P2 equal to P, the value of sine 45 degree is 1 by root 2. It is 105 degree. 105 degree. Now, perhaps you have understood up to this. Now find the value of sine 105 degree. Now sine 105 degree equal to sine 180 degree minus 75 degree. This is equal to sine 75 degree. This is equal to sine 45 plus 30 degree. This is equal to sine A cos B plus cos A into sine B. Cos A into sine B. This is equal to 1 by root 2. It is root 3 by 2 plus 1 by root 2, 1 by 2, root 3 plus 1 divided by 2 root 2. Root 3 plus 1 divided by 2 root 2. Sine 105 degree equal to this. Therefore, P1 equal to, therefore P1 equal to, from this text, therefore P1 equal to P root 3 by 2, and it is root 3 plus 1 divided by 2 root 2. It is equal to P root over 3 root over 2. 2 will be cancelled. Root 3 plus 1. This is equal to root 6P divided by root 3 plus 1. P1 will be equal to this. And P2, what is P2? There also P2 equal to. P2 equal to P into 1 by root 2. Put the values root 3 plus 1 divided by 2 root 2. Divided by 2. This is equal to 2P by root 3 plus 1. 2P divided by root 3 plus 1. P1 is equal to root 6P by root 3 plus 1. It will be equal to 2P divided by root 3 plus 1. In the last class, I solved one problem. The resultant is near, two forces are acting at a point. The resultant of the two forces is nearer to the greater force. Nearer to the, here it is definitely the resultant of P1 and P2 is equal to P. Root over 6 P divided by root 3 plus 1 is obviously greater than 2P divided by root 3 plus 1. The resultant is nearer to this one. Am I right? Yes. This one. Therefore, we have solved number 1. Number 1, today's number 1 and as a whole number 23. As a whole number 23, this problem has been solved. Root 6 plus 1? Yes. We have solved this. We have solved number 23. It has been solved. Let me remove this one. This has been solved. Now let us try to solve the number 2. Today's number 2 and as a whole question number 24. Let us try to solve this question number 24. What is this 24? Two forces of magnitude P and Q, whose resultant is of magnitude R, act at an angle alpha. This is first part. First condition is given. When P and Q both increase by R, both are increased by R, prove that the resultant turns through an angle theta. This means P and Q, suppose this force is P, magnitude, I have written magnitude this force. Magnitude of the force Q is also Q. Suppose the resultant is this. This is the resultant of this. Resultant of P and Q. This angle is alpha. It is given. It is given that this angle is alpha. Suppose the resultant makes an angle phi with the force P. And if it is increased by P plus R, it is also increased by R. P will become P plus R. If it is increased by R, the force will become Q plus R. Then the new resultant will turn through an angle theta. New resultant, suppose this is the new resultant, R1. Turn through an angle theta. Turn through an angle theta. When tan theta is equal to this. Theta given by tan theta is equal to this. Now, suppose the new resultant makes an angle phi dash. Makes an angle phi dash with the direction of the force P. Now we have to show that tan theta equal to this. Let us proceed. The first part is given like this. What is this? Magnitude of P and Q is R. It is given, and it is the two forces are acting at an angle alpha. It is also given. First condition. Since you may write since R is the resultant of P and Q, I am not writing the vector sign. This means that I am writing the magnitude of the forces. This is the the magnitude of the force P vector equal to P. Magnitude of the vector Q is also Q. Magnitude of the vector means force R vector is R. Is the resultant of P and Q. P and Q are acting at an angle alpha. Therefore, R square equal to P square plus Q square plus twice PQ cos alpha. Suppose this is the number. R square is equal to P square plus Q square plus twice PQ cos alpha. Suppose the resultant R makes an angle phi with the direction of the force P. Suppose the resultant R means the magnitude of the result makes an angle phi with the direction of the force, P. Therefore, tan phi equal to Q sin alpha divided by P plus Q cos alpha. Obviously this. If P and Q are increased by R. Second part, if P and Q increased by Q are increased by R. That is, if P becomes P plus R and Q becomes Q plus R. That is, if the forces P and Q become P plus R and Q plus R respectively, then let R1 be the new resultant. So that ROR dash, this angle, this is equal to theta. This angle is equal to theta. Let R1 vector means the new resultant. Makes an angle phi dash with the direction of the force P, with the direction of the force P, means with the direction of the force P. Thus, I have written the magnitude of the force P. Therefore, tan phi dash will be equal to what? What will be tan phi dash? Will be equal to, here tan phi dash equal to Q plus R sin alpha divided by, for P you will have to write P plus R, Q plus R cos alpha. Suppose this is number 3. Now, this is number 3. Obviously, or clearly, if we write clearly, theta equal to phi dash minus phi. Clearly, theta is equal to phi dash minus phi. From the diagram, theta is equal to this phi dash minus phi. We have to show that tan theta is equal to this. Now, therefore, tan theta equal to tan phi dash minus phi. This is equal to you may write tan phi dash minus tan phi divided by 1 plus tan phi dash tan phi. Tan phi dash. Now, from 3, put tan phi dash equal to this, and from 2, tan phi equal to this. Also suppose the number 1. What was 1? What is 1? R square is equal to p square plus q square. P square, it will be applied later on. Twice pq cos alpha. It will be applied later on. Let me write this one. Tan theta is equal to this. Therefore, tan theta equal to. What is tan phi dash? Equal to this. Q plus R. Sin alpha. Sin alpha divided by Q plus R sin alpha. Divided by P plus R. Plus Q plus R. Cos alpha. For tan phi dash equal to this, minus tan phi Q sin alpha divided by P plus Q cos alpha divided by 1 plus, for tan phi dash you should write this one. Cos alpha into, for tan phi write this Q sin alpha divided by P plus Q cos alpha. You may write here using 2 and 3. Using 2 and 3. 2 and 3. That's right. Therefore, I can remove this one. Now, tan theta, after calculating this one, after simplifying this, we must get this one. We must get this one. This means tan theta equal to. Tan theta equal to. Let me write it. Tan theta equal to. Just simplify this. Q plus R sin alpha into this P plus Q cos alpha minus Q sin alpha into P plus R plus Q plus R cos alpha. Q plus R cos alpha. Q plus R cos alpha. Divided by this into this, you may write this into this. P plus R plus Q plus R cos alpha into P plus Q cos alpha plus Q sin alpha into Q plus R into again sin alpha. Right? Let me simplify this one. Simplify this. What will be this? Just simplify this. This is equal to multiply this and this. PQ sin alpha. It will be PQ in the numerator. First, I am writing in the numerator PQ sin alpha plus RP sin alpha plus Q square sin alpha cos alpha. Just multiply this. Simplify. Plus Q or sin alpha cos alpha cos alpha minus PQ sin alpha minus QR sin alpha again minus Q square sin alpha cos alpha again minus QR sin alpha cos alpha. Just simplify this. QR multiply this and this. QR sin alpha cos alpha. Just we have written the numerator. Just write the denominator. What is the denominator of this? It will be simply p square. It will be p square plus PR plus PQ cos alpha plus PQ cos alpha plus RP cos alpha plus Q square cos square alpha. Multiply this and this. Cos alpha is already multiplied. Q square cos square alpha plus Q square cos square alpha plus QR again cos square alpha. Now write this one. Q square sin square alpha plus QR sin square alpha. QR sin square alpha. Perhaps we have written all the terms. Have we written all these terms? PR, let me check once again. P square plus PR plus PQ cos alpha plus PR or RP cos alpha plus this term. We have written this term and this term. Q square cos alpha, but I have not written this and this plus PQ cos alpha. Just 1 minute, 1 second. We have written this one. P square plus PR plus PQ cos alpha plus PR or RP cos alpha. RP cos alpha. Yes. This term and this term. These two terms have not been written here. From let me write this. I am sorry. Plus PQ cos alpha. Plus QR cos alpha. These two terms were dropped. Plus Q square cos square alpha. Plus QR cos square alpha. Now Q square sin square alpha plus QR sin square alpha. Now it is right. Now see the numerator. PQ sin alpha will be cancelled. PQ sin alpha will be cancelled. Q square sin alpha cos alpha plus and minus. These terms will be cancelled. Also these terms also will be cancelled. And in the numerator, just let me write here again. Now, in the numerator, this means tan theta equal to RP sin theta sin alpha minus QR sin alpha. R is common. R is common. P minus Q sin alpha. P minus Q sin alpha. Here, you may write P square plus PR plus, it is PQ cos alpha, PQ cos alpha, PQ cos alpha, means twice PQ cos alpha plus RP cos alpha plus QR cos alpha plus QR cos alpha plus Q square into sin square alpha plus cos square alpha, cos square alpha plus sin square alpha plus and QR into cos square alpha plus sin square alpha. QR into cos square alpha plus sin square alpha. Now this means tan theta equal to, in the numerator you may write R P minus Q sin alpha. Now in the denominator, P square plus Q square, first write this one. P square plus Q square. This is equal to 1 and this is equal to also 1. Q square. Next write this one. Twice PQ cos alpha plus PR plus, write this term, QR. Since this is equal to 1, therefore it is Q square. PR, QR. From these two terms, you may write R into P plus Q cos alpha. You may write like this, P plus Q cos alpha, right? Now, this means tan theta equal to R P minus Q sin alpha. By 1, you may write here R square plus PR plus QR plus R P plus Q cos alpha. Since R square equal to P square plus Q square plus twice PQ cos alpha. By 1, now dividing numerator and denominator by R. Now divide numerator and denominator by R. Then you will get P minus Q sin alpha. It will be R plus P plus Q plus P plus Q cos alpha. Dividing numerator and denominator by R. And denominator by dividing numerator and denominator by R. P minus Q sin alpha. You may write P plus Q plus R, P plus Q plus R plus P plus Q cos alpha. You see, the question number 24 has been solved. We have solved the question number 24. We have done this one. Now, finally, I am going to solve the question number 25. Finally, I am going to solve the question number 25. Perhaps you have understood this one. It is not tough. Just calculation should be done very carefully. Then the problem will be very easy. Now, question number 25. I am going to solve the question number 25. What is this? You see, if the forces P, Q, R act at a point parallel to the sides BC, CA, AB respectively of a triangle ABC, Suppose ABC be a triangle. Suppose ABC is a triangle. ABC be a triangle. P is acting parallel to BC. PQR are acting at a point. Suppose this is P force, and it is parallel to BC. Q force, it is parallel to CA, and R, it is parallel to AB. It is parallel to AB. Right? Suppose F bar be the F vector be the resultant of the forces P, Q, and R. F vector be the resultant of the forces P, Q, and R. Then we prove that the magnitude of the resultant should be equal to this. We are going to find the magnitude of the resultant. Suppose I cap and J cap be the, suppose J cap, this is J cap, be the unit vectors along and perpendicular to BC. Along this vector it is I cap, and perpendicular to BC the unit vector is Z cap. Let's see. Very easy and very interesting to know, nothing to be out of the way. It is given in the question, PQR are acting at a point. Let, you may write, let the forces PQR are acting at the point O. At the point O, parallel to BC, CA, and AB of the triangle ABC. Parallel to BC, CA, and AB of the triangle ABC. Of the triangle ABC. Of the triangle ABC. Let a vector be the resultant of the forces PQ and R. Therefore, F vector should be equal to P plus Q plus R. F vector should be equal to P plus Q plus R. Therefore, we will get this one. Let I cap and J cap be the unit vectors. I cap and J cap be the unit vectors along and perpendicular to BC. since P vector is acting parallel to BC, therefore I cap will be this one, and a vector which is perpendicular to BC, it will be J cap, the unit vector J cap. Let theta be the angle. Let the resultant F makes an angle theta. Angle theta with the direction of BC with the direction of I cap. Suppose this angle is theta. This angle is theta. Now, resolving the process, the forces along and perpendicular to BC, we get resolving the process along and perpendicular to BC, we get F vector dot I cap dot I cap. It is you may what is this? The result parts of any process along any direction. This is equal to the result part of the resultant along the same direction. This is the theorem. First, along BC we have written the result part of this. Sum of the result parts of any process along any direction. This is equal to the result parts of their resultant along the same direction. We have applied this one. Now, perhaps we have written this. Let's do that. F vector dot I cap. This means magnitude of this is F. I cap, magnitude of I cap is equal to 1. What is the n into cos? Cos of angle between F and I equal to theta. F and I equal to theta. Cos theta. This is equal to, yes, this is equal to P into 1 into, it will be cos 0. Cos 0. It will be cos 0 plus Q into 1 into the angle between Q and I. What is the angle between Q and I? It is acting in this one. Suppose this angle is P, right? This angle is P. We have to find the P and unit vector along this direction is I. What will be this angle? This angle will be equal to pi minus C, because this angle is equal to C. It will be equal to pi minus C. Cos pi minus C. Cos pi minus C, right? It is cos pi minus C. Plus R means this angle. What will be this angle? This angle. It is along this direction. Suppose I am writing here. It is B. It is B. This. It is B. The angle this and this. This angle is B. This angle is B. Therefore, This angle is B. What will be this angle? From this and this it is pi. Therefore, this angle will be equal to pi plus B. Pi plus B. This angle is equal to pi plus B. Pi plus B. Therefore, it will be equal to R cos pi plus B. Right? This means F cos theta equal to P cos pi minus C equal to minus cos C. Therefore, P minus Q cos C R cos pi P pi plus theta equal to minus cos theta. If it is equal to minus R cos B. Suppose this is number 1. This result has been obtained if we take the result parts of the forces along the direction BC. Now, if you take the result part of the force along the direction J cap, means along a direction which is perpendicular to BC, then you will get F factor also F factor dot J cap equal to P dot J cap plus Q factor dot J cap plus R vector dot J cap. Sum of the result parts of any forces of three forces P, Q, R along the direction J cap. This is equal to the result parts of their resultant. Their resultant is F vector. Now, this means F magnitude magnitude of F vector is F. Magnitude of J cap is equal to 1 into cos. What is the angle between F and J? See the diagram. F and J, this angle is theta. This angle will be equal to pi by 2 minus theta. Definitely it will be pi by 2 minus theta. Pi by 2 minus theta. Pi by 2 minus theta. This is equal to P cos I cap and J cap. The angle between I cap and J cap equal to 90 degree. It is 90 degree plus Q and J cap. Find the angle between Q and J. Means this angle. What will be this angle? Means what will be this angle? Means write this one. It is J cap. It is P vector and it is Q. It is Q. Also, this is R. It is R. Suppose it is Q. What is the angle between this and this? This angle. The total angle, this angle is equal to pi by 2. This is C. It is pi by 2 minus C. This angle is equal to pi by 2 minus C. You will have to write cos pi by 2 minus C plus R. R and J. Suppose this one, this angle. It is R. And J. This is J. We have to find this angle. Now you see here the vertically opposite angle. These two angles are equal. This angle is B. This angle will be equal to B. Means this angle is equal to B. This is B means this is B. This is equal to pi by 2. Therefore, the angle between R and J will be equal to pi by 2 plus B. It is pi by 2 plus B. Just see carefully. This is B, this is B. Means this angle is B, this angle is B. The angle between this and this is pi by 2. Therefore, this angle will be equal to pi by 2 plus B. Pi by 2 plus B. r cos pi by 2 plus b. This means f sin theta equal to, it is p into 0, it is 0, plus q, it is sin c, pi by 2 minus theta sin c, pi by 2 plus theta, it will be equal to minus r sin b, minus r sin b. This means f sin theta equal to, it is 0, q sin c minus r sin b, r sin b. Suppose this is number 2. This is number 2. Squaring and adding 1 and 2 we get. Adding 1 and 2 we get. Squaring and adding 1 and 2 we get. F square cos square theta plus sin square theta. This is equal to P minus Q cos C minus R cos B minus R cos B whole square plus Q sin C minus R sin B whole square. Right? Now calculate this one. Simplify this. First, let me write it here. This implies B square, F square equal to A plus B plus C whole square, in that formula, right? B square plus Q square cos square C Q square, this cos square C plus this sin square C. Cos square C plus sin square C. R square cos square B plus sin square B. Sin square B. There will be 6 terms here. There will be 3 terms here. In total, we will get 9 terms. We have already written 1, 2, 3, 4, 5 terms. Another 4 terms will have to be written. Now, minus twice PQ cos C minus twice PQ cos C minus twice RP cos B cos B plus twice QR cos B cos B. All the terms have been written from this. And minus twice QRs, minus plus twice QR cos B into cos C. Cos B into cos C. Cos B into cos C. Minus twice QR sin B into sin C. Sin B into sin C. All the 9 terms have been written. 1, 2, 3, 4, 5, 6, 7, 8, 9. 7, 8. We have written all the 9 terms. This means F square equal to P square plus Q square plus R square minus twice PQ cos C minus twice RP cos B minus twice QR plus twice QR, you write cos B cos C minus sin B sin C cos B cos C minus MB sin. This means F square equal to P square plus Q square plus R square minus twice PQ cos C minus twice RP cos B plus twice QR cos B plus C. Cos A cos B minus sin B sin A sin B equal to cos A plus B cos B plus C. This means F square equal to P square plus Q square plus R square minus twice PQ cos C minus twice RP cos B. It will be plus twice QR cos pi minus A. Since ABC is a triangle, A plus B plus C equal to pi. ABC is a triangle, A plus B plus C equal to pi. Therefore, B plus C will be equal to pi minus. This means F square equal to P square plus Q square plus R square minus twice PQ cos C minus twice RP cos B. It will be minus twice QR cos A minus QR cos A. This means F equal to root of R. It will be root of R. P square plus Q square plus R square. First write this one minus twice QR cos A minus twice RP cos B minus twice PQ cos C. Write this one. Am I correct? QR cos A, RP cos B. This is equal to the magnitude of the resultant of PQ, which is equal to magnitude of the resultant of the forces P, Q and R. Magnitude of the resultant of the forces P, Q and R. This is equal to this. Dear students, perhaps you have enjoyed the class. Thanks for attending the class. Thank you very much. Thank you.